The two blocks shown in figure are initially at rest. These two blocks are at rest. Assuming ideal pulley and strings and neglecting friction to all surface, find the acceleration of the two blocks and tension in the cable. Now here we will see, let the acceleration of this block be A and the acceleration of block B be AB. Then we know by constant, if we stop this block A, this block B will stop. So by constant we can say there is a relation between the acceleration of this block A and B. So we will watch a video which we have already seen, lecture under constant relationship. So we will watch this video. Now this block A, when this block A is moving forward, this block B is going downward. The speed of block A is more as compared to speed of this block B, because here where we get a string and here we need a string. By constant we know the acceleration of A is equal to 3 times acceleration of B. If you see this motion, now here we know by constant acceleration of block A is equal to 3 times acceleration of block B. This is our first relation. Since the tension in the string, let it be T. Here the tension is T, here tension is T, here tension is T. So we will draw the free body diagram of this block B, and here we will draw the free body diagram of this block A. So from the free body diagram of this block A, we can say the tension in the string is T, that is equal to mass, it is 30 into acceleration of A. This is our first relation. From this B block, the weight of this block will act downward, so we can say 250 minus the upward tension is Tt and T, it is 3T, that is equal to mass of this block B is 25 multiplied by acceleration of block B. This is our third relation. This is our second relation. Now from first, second and third relation we can say acceleration of A means T by 30 is equal to, I will substitute the value of A here and AB here, then I get T by 30 is equal to 250, it is 250 minus 3T divided by 25 into 3. So from here we can say it is 6 and it is 5. So it is, here we can say T into 5T is equal to 18 into 250 minus 3T, or 5T is equal to 18 into 250 minus 18 into 3T. So from here we get T is equal to 18 into 250 divided by 5 plus 18 into 3, which is equal to, here we can say it is 18 into 250, which is equal to, it is 4500. It is 5 plus 18 into 3, that is equal to 59 divided by 59. So 4500 divided by 59 is equal to, this is equal to 76.3 Newton. This is the tension in the string. This is the first part of our answer. It is approximately written here 76 Newton. If I substitute the value of T here, then I get acceleration of A, and acceleration of A is T 76.3 divided by 30, that is equal to, it is 2.54 meter per second square. In the same way, acceleration of B is 2.54 divided by 3. It is 2.54 divided by 3, which is equal to 0.85 approximately meter per second square. So this is the tension in the string, this is acceleration of block A, and this is acceleration of block B. So this is our answer. Now here two block of mass 2.9 kg and 1.9 kg are suspended from a rigid support by two inextensible string of length 1 meter. This length is 1 meter and this is also 1 meter. The upper is negligible mass, but this is of mass 0.2 kg. This is having mass. This rope is not massless, it is having mass, and here mass density is lambda is equal to 0.2 kg per meter. So total mass of this rope is 0.2 into 1, that is 0.2 kg. The whole system is blocked. The whole system of the block wires and the support has an upward acceleration of this. The acceleration due to gravity is 9.8. Find the tension at the midpoint of the wire. Now we have to calculate the tension at the midpoint of the lower wire, means here. Now we can say let the tension here is T. So we can say T, let this be T naught. So T naught minus mg. Mg means it is 2.9 plus 1.9 plus 0.2. The total weight of this. We are drawing the free body diagram of this whole system. Into G means it is 9.8 is equal to mass means it is 2.9 plus 1.9 plus 0.2 into acceleration. Here acceleration is 0.2 meter per second square. So from here we get T, that is equal to 2.9, 1.9, it is 2, 3, 4, 5, it is 5 into 9.8 plus 0.2 is 10. So tension here is 50 Newton. This is T naught. Now we have to calculate tension at the midpoint of this rope. Now we can say the tension here, let it be T. Tension at the midpoint of the rope is T minus mg. Mg means the weight of this portion only. We will consider only this portion. We have to calculate the tension at the midpoint. So the tension here is mg means 2. It is 1.9 plus 1 plus 0.1 because we are taking or considering only half of the length of this rope. So it is 2 into g means 9.8 plus is equal to mass means 2 into acceleration means 0.2. So we get tension that is equal to 20 Newton. So at the midpoint the tension here is 20 Newton. At this point on the upper wire the tension is 50 Newton because this is massless. So the tension in the upper wire is 50 Newton and the tension at the midpoint of this lower wire is only 20 Newtons. Now here if the mass of block A is 5 kg, this is block A, its mass is 5 kg, whereas mass of block B is 10 kg. Now we have to find the acceleration of A. A, the value of A means acceleration of block B with respect to ground. So as we know, when this block is moving horizontally with acceleration A, the acceleration of this block comes out to be A, and in downward direction it is 2A, as we can see it from this video. Watch the motion of this block A and block B. When this block B will move forward, this block B A is moving forward as well as downward, and the acceleration, the motion of this A and B is related. We can see the constant relation between them. See the constant. This is the motion for constant. If we see this triangle, the length of this triangle, the vertical height is double to that of the horizontal height. So means this block is moving horizontally with acceleration A and vertically it is moving with acceleration 2A. So we can say the horizontal acceleration of this block A is A and vertical direction the acceleration is 2A. So I will draw the free body diagram of this block A. The free body diagram of this block A means it is T. The tension here will act upward. The weight of this block is 50 Newton. It is acting downward, and the downward acceleration, there is one more reaction, that is R. So we can say 50 minus T is equal to 5 into 2A. This is our first relation. In the same way, this block is also moving horizontally, so we can say the horizontal reaction is mass into horizontal acceleration. This is A. This is our second relation. These are the two relation for block A. In the same way, if we draw the free body diagram of this block B, so I will separate this block B from here, and I can write the free body diagram like this. This is our block B. This is pulley. Here the tension is acting in this direction. Here it is in this direction. Here the tension is acting in this direction. The reaction force is in this direction, and there is no friction. So we can say the total horizontal force acting on this block B is 2T minus R, and that is equal to mass of this block B, that is 10 into A. This is our third relation. So from this relation there is three unknown T, R and A. So from first, second and third I can say 2T, R means 5A is equal to 15A. I will substitute the value of R here. So I get 2T is equal to 15A. This is our one more equation. Now from this first equation and from this equation we can say, I will substitute the value of T here. So we get 50 minus T means it is 15 by 15A by 2, that is equal to 10A, or A comes out to be 100 by 20 plus 15, that is 35, or that is equal to, it is 20 by 7 meter per second square. So acceleration of block B is 20 by 7 meter per second square, and this is the answer. Now here this is a question based on balloon. The force of buoyancy exerted by atmosphere on a balloon is B. This is the buoyant force which is acting on this balloon, and this force is B in upward direction and remains constant. This is constant force. The force of resistance of the balloon acts opposite to the direction of velocity and is proportional to it. This is also called drag force. If the balloon carries a mass m and is found to fall near the earth's surface with constant velocity v, the balloon is going downward with a constant velocity v. Since it is going downward, so drag force will act upward, and we can say this drag force, let it be F naught. This is the drag force, the air resistance force. The question says the drag force always acts opposite to the velocity of this balloon. So the drag force here is acting upward. Now the weight of the balloon is, the total weight of the balloon is m into g. And since it is going downward with constant speed, so we can say in that situation the total weight Fd plus buoyant force must be equal to m into g. This is our first relation, because speed is constant, so the net force is balanced. The balloon, how much mass should be removed from the balloon so that it may rise with constant velocity v? Now suppose from the same balloon, let mass small m be dropped from it. So the total mass of the remaining balloon is m minus m, and the buoyant force is acting upward. This is B. Now this balloon starts moving upward, so the drag force will act up downward, that is F naught, and the weight of this balloon is m minus small m into g. This is the weight which has been, this is the mass which has been dropped from this balloon. Now in this situation the drag force will remain same because the velocity is constant. So second equation, our second equation becomes B is equal to drag force plus m minus small m into g. This is our second equation. Now from our first equation, we know first equation is F naught plus B is equal to mg. So it is F naught plus B must be equal to capital M into g. This was our first equation. If we add these two equations, we get 2 times buoyant force is equal to 2 times capital M minus small m into g. So from here we can say m into g must be equal to 2 times capital M g minus 2 times buoyant force. So from here small m comes out to be 2 times capital M minus b by g. So this is the answer. This is the mass which must be dropped from the value. Now find the acceleration of block A and B in the situation shown in this figure. This angle is 37 degree, it is given. The mass of this block is 5 kg, the mass of this block is 10 kg. Let the acceleration of this block be A naught, let the acceleration of block B be A1. Now we also know A naught must be equal to A1 into tan 37. Tan 37 means it is 3 by 4. This is our first relation. This is the relation between the acceleration of these two blocks. This is the constant relation. Now the second one, if we draw the free body diagram here, the normal reaction on this wedge will act like this, and here the normal reaction will act in this direction. This angle, we can say this angle is 37 degree, so this angle is 53 degree. If this is 53, I can say this angle is 37, so this angle is also 37 degree. This angle is 53 degree. Now if we draw the free body diagram of this block, we can say in this situation the normal reaction, horizontal component of normal reaction is n sin 37. The vertical component of normal reaction is n cos 37, and the weight here is 50. Since this is going downward with an acceleration a naught, so we can say 50 minus n cos 37 degree is equal to 5 into a naught. This is our second equation. In the same way, if I say the horizontal force on this triangular wedge is also n sin 37 degree, and this n sin 37 degree is equal to 10 into a1. This is our third relation. From these three relations, first, second and third, we can say from this second equation, we can say 50 minus n cos 37 means it is 4 by 5 is equal to 5 a naught, and from this equation we can say n into n into sin 37 means 3 by 5 is equal to 10 into a1. Now if we substitute the value of a naught, from here we can say a naught is equal to 50 into 5 minus 4n divided by 25. In the same way, from here we can say a1, that is equal to 3n by 50. Now if I substitute the value of a1 and a here, we get a naught is equal to 3 by 4 into a1, and we know from this equation a naught is equal to 50 into 5 means 250 minus 4, it is 250 minus 4n divided by 25 is equal to a naught, and a1 is equal to 3n by 50. a1 is equal to 3n by 50. I will substitute the value of a1 a naught here, so 250 minus 4n divided by 25 is equal to 3 by 4 into a1. a1 means 3n by 50. So this will cancel out, it becomes 2 on 4 into 2, that is equal to 8. So it is 8 into 250 minus 8 into 4n is equal to 9n. So from here we get n is equal to 8 into 250 divided by 41. This is our n, which is equal to 250 is equal to this divided by 41 is equal to, this is equal to 48.78, can be written as 8 Newton. This is the normal reaction. In the same way, I can say a1 is equal to 3 into 48.8 divided by 50. So this is equal to, it is 3 into 48.8 is equal to this divided by 50 is equal to 2.928. That can be written as approximately this is 3 meter per second square. In the same way, A2 comes out to be A naught is equal to A naught is equal to 3 by 4 into A1. So it is 9 by 4 meter per second square. So this is A1, this is A naught, and this is normal reaction. This is the contact force between this rod and this triangular wedge. Now here a block is kept on floor of an elevator at rest. This is an elevator which is at rest. The elevator starts descending with an acceleration. The acceleration of elevator that is equal to 12 meter per second square. Find the displacement of the block in first 0.2 second after the start. Now if this accelerator starts, this acceleration of this elevator is more than g, that is equal to 10. If this lift starts moving downward with an acceleration more than 10, this block will be in free fall. So block is in free fall. Means it lose contact with this elevator, and in that situation the acceleration of this block is only 10 meter per second square. So we can say the displacement is 1 by 2. A means it is 10 into 0.2 into 0.2. So it comes out to be 0.2 meter, or that is equal to 20 centimeter. This is the answer. You can never use 1 by 2 A into T. Here A can never be 12 meter per second square, because this block will fall with an acceleration that is equal to 10 meter per second square. A ladder is hanging from the ceiling as shown in this figure, and the three kids of mass 10 kg. The mass of this kid is 10 kg. The mass of B is 12 kg. The mass of C is 8 kg. These are the three kids who are moving on this ladder. A is going downward with an acceleration of 1.6 meter per second square. B is going upward with acceleration 0 with a constant speed. C is also going upward with a constant acceleration of 0.9 meter per second square. Now suppose this kid A exert a force F1 here on this ladder, this kid B exert a force F2, and this kid C exert a force F3. So if we draw the free body diagram of this kid A, then the force here is F1, the weight of this kid is acting downward, that is 100 Newton, and he is going downward with an acceleration A. So we can say F1, it is 100 minus F1, that is equal to 10 into 1.6. So from here we can say F1 is equal to 100 minus it is 16, that is equal to 84 Newton. This is the force exerted by this kid 1 on this ladder. In the same way, this kid B, this B is always going with a constant speed. So the force F2 is equal to its weight is 120 Newton. So we can say F2 is equal to 120 Newton. This is the force exerted by kid B. And in the same way, this kid C is going upward with an acceleration of 0.9. So let this be F3, and the weight here is 80. So we can say F3 minus 80 is equal to 8 into 0.9. So F3 comes out to be 80 plus 8 into 0.9. So it is equal to 87.3 Newton. 87.2 Newton. So the total force experienced by this ladder is T naught, and this T naught is equal to F1 plus F2 plus F3, which is equal to F1 means 84 plus 120 plus 87.2. Now if we add these three, we get the tension that T naught comes out to be, here it is 84 plus 120 plus 87.2. It is 87.2. That is equal to 291.2 Newton. So this is the total force experienced by this string. So this is the tension in the string. Now the next question is, a painter of mass m, the mass of this painter is m, he is standing on a platform of mass small m and pull himself by two ropes. Let he apply a force F on this rope and move up with an acceleration A. Let the acceleration be A. So we have to calculate this A. So if we draw the free body diagram of the whole system, this is force F, this is force F, this is force F, this is force F. So the total weight is M plus capital M into G. So the upward force here is 4F and the downward force is M plus capital M into G. That is equal to mass into acceleration M plus capital M into A. The whole system is moving with an acceleration A. So from here we can say A is equal to 4F by M plus capital M minus G. This is the answer. Now a small ball of mass 1 kg, the mass of this ball is 1 kg, which is being dropped from height 5 meter. This height is 5 meter from the ground. The ball goes 0.5 centimeter inside this sand. This distance is 0.5 centimeter and comes to rest. Find the average force during the force on the ball by the sand. So when this this boy drop a ball from 5 meter height, this ball strikes the surface with some speed v0 and this v0 is equal to root over 2gh. So from here we get to root over 2g is 10 and h is 5. So it comes out to be 10 meter per second. So this ball strikes with a speed of v0, that is 10 meter per second. Now final distance, the distance traveled by this ball inside this sand is 0.5 into 10 to the power minus 2 meter. This is the distance and the final velocity becomes 0. So we can say v square is equal to u square minus 2as, because there is a retardation. So let the retardation be a. So final velocity is 0 square is equal to v0 square minus 2as. So a comes out to be v0 square by 2s. That is equal to v0 square means 10 into 10 divided by 2 into 1 by 2 into 10 to the power minus 2. So this will cancel out. It comes out to be 10 to the power 4 meter per second square. Now if this is the average acceleration, we can say the average force is mass into average acceleration, which is equal to the mass of the ball is 1 kg and the acceleration or retardation of the ball is 10 to the power 4 meter per second square. So this is equal to 10 to the power 4 Newton. This average force is very large as compared to the weight of this ball, because the weight of the ball is only 10 Newton and the average force is 10 to the power 4 Newton. So we have neglected the weight of this ball during penetration inside this sand. A balloon is descending with a constant acceleration a less than the acceleration due to gravity. The weight of the balloon with its basket is w. The total weight of the ball, this basket and this content balloon is w. So it is w Newton downward. What weight w of the blast should be released so that the balloon will begin to accelerate upward with a constant acceleration a? Now suppose this balloon is going downward, let the buoyant force is acting F upward. This is the drag buoyant force. So we can say W minus F is equal to mg. M means W by G into A. The mass of this balloon is weight by G. This is the actual mass of this balloon and this content. This is our first equation. Now when the person drops something from this balloon, then in that situation let the mass drop be, this is W which is dropped from this balloon. So the weight of this remaining portion is now, it is acting downward, it is W minus capital W, and the upward buoyant force will remain same. So in this situation we can say F minus W is equal to mass of the remaining portion is W minus total weight by gravity into A. This is our second equation. Now we know from first and second expression, we know the our first expression W minus F is equal to W by G into A. This is our first equation. From this first and second, if we add first and second, we get this F will cancel out, we get W minus W plus capital W is equal to 2 small w minus capital W into A by G. So this will cancel out, we get G into capital W is equal to 2 small w into A minus capital W into A, or from here we can say capital W, that is equal to 2W into A divided by G plus A. This is the weight of the body which must be dropped from this balloon.